All right, part B. So part A, we were looking and finding inverse operations. Now we're gonna talk about actually looking at it from a function perspective and focus on specifically the quadratic and the square root function, okay? So our last forever units that took forever were all about the quadratic, right? F of x equals x squared, remember that? And so here we have our origin at 0, 0. We have a point here at 2, 4. We have a point here at negative 2, 4. And so that's our square root function, right? Our quadratic, I'm sorry. So here's our quadratic. Now we're going to focus on the square root function. Okay, right now, the square root, this isn't a function. So if I found the inverse of the quadratic is the square root, right? So instead of it being vertically concaved up, it's now horizontally concave to the right. Do we see that? But what does it fail? What does that test called? It fails the vertical line test. Because that's how we test to see if something is a function. And this fails the vertical line test. I hit more than one point at a time. So as it is right now, it is not a function. It's just a relation. So this is a relation, not a function. Okay, it's like a real relationship. Sometimes you're in a relationship. You may be in a relationship, but is it a functioning relationship? That's the question. Okay, so this is a relation, but it's not functioning. Okay, now in order for this to work and to be a function, an inverse function, we have to have restrictions. So we have to restrict the function. Okay, just like any healthy relationship, there has to be restrictions and boundaries. Okay, same thing here in math. There has to be restrictions and boundaries. Okay, so here, in order for this to work, in order for my inverse to work, I have to restrict my quadratic. So it can't be the entire quadratic. It can only be a piece of the quadratic. So my restriction here is x is greater than or equal to 0. And when I do that, when I say I'm only going to use x is greater than or equal to 0, look at this. I now am functioning. I now pass the vertical line test. So this is the square root function. Okay, it's a healthy relation. And when we look here, we know that it's a square root function. If you look at the values, so here I am at 2, positive 4. If I am an inverse, that means my x and y do what? Switch places, right? So on the other graph, I should be at 4, 2. I come over here to 4, I go up, and look at that, 4, 2. Okay, so we have to restrict the domain when we're going from a quadratic to a square root so that it can be a function, a healthy relation. Okay, so let's talk about some attributes here. Here we have a graph. When you have a graph of an inverse, you know that they're inverses of each other because they are symmetrical along the y equals x line. So they are symmetrical along the y equals x line. So from this point to this point. And so if you look here, I'm at 1, 3. This point's at 3, 1. You see that? Okay. So they're symmetrical along the y equals x line. That's a visual representation of inverses. Now we're going to talk about the domain, the range of f and the domain of the inverse. So if we look at f, our square root function right here, what is the range of it? So range, remember, is from bottom to top. What is the lowest this function goes? And then it goes on forever to infinity, right? So the range for f is y is greater than or equal to 0. So, because that means it goes on forever, right? I have no stopping point. There's no boundary, okay? The domain of the inverse, so that is not how you spell domain, y'all. domain of the inverse. So if I look at the inverse, what is its domain? Remember, domain is from left to right. So where do I start at on the left? Left. I start at 0, right? Yeah? Huh? So not bottom to top, we're looking at domain, and domain goes left to right, the x value. So my lowest x value here is 0. So we're at 0, 2. So I start at 0 and then I go on to infinity. So my domain is x is greater than or equal to 0. What do you notice about the range and domain here? Do they have the same inequality? Yeah, they have the same inequality. And that's because the domain and range of a function and its inverse are going to have the same restriction, the same boundaries. Okay. Now, if we look at the domain of our, so if we look at the domain of our function, so looking here at the domain again is from left to right. So I'm here at 2, 0. What is the smallest value I'm at? 2, right? And then I go on forever to infinity. So my domain is x is greater than or equal to 2. My range of my inverse, range is from bottom to top. So my lowest y value is 2, and I go on forever. So my range is greater than or equal to 2. Again, same inequality, just different variable, right? So if I know one, then I automatically know the other, okay? And that's because the inverse relation is true for all relations whenever both f and inverse of f are defined. Okay, so let's analyze one together. So here's our new graph. They only gave us the function, the square root function. So we have f of x equals the square root of 3 minus x. And it wants us first to define the domain. So looking at this function, what is my domain? I start at 3, right? Am I greater than 3 or less than 3? Why is it less than? It's going towards negative infinity, right? I'm heading towards negative infinity. So my domain is x is less than or equal to 3. Okay. What is the range of my function? So from bottom to top, what is the lowest y value? 0, and then it goes on forever to infinity, right? So am I greater than or less than? Greater than, good job. Y is greater than or equal to 0. So those are that's the domain and range of my given function. And because I have those values, I can say what the domain and range of my inverse would be. That's because my domain of my original function tells me the range of my inverse, and the range of my original function is going to tell me the domain of my inverse. So the domain of my inverse, since domain is x, what is the inequality that it should be? Greater than or equal to 0. The domain of my inverse is going to be the opposite, well, the same as the range of my original. The range of my inverse is going to be the same as the domain, but instead of x, I'm talking about what? Y, right? We're talking about y. So it's going to be y is less than or equal to 3. So I can take a sketch here. So right now I'm at 3, 0. To find its inverse, I'm going to switch x and y. So instead of being at 3, 0, I'm now going to be at 0, 3. Finding a couple more points on here. Currently, I'm at 2, 1. So instead of being at 2, 1, I'm going to be where? I'm going to be at 1, 2. Okay. And then I have another point here at -1, but I'm not gonna be able to really do it, but we'll see if we can make it. Yeah. So the other point here that I have is at -1, 2. Switch my X and my Y, and that puts me at 2, -1. So now I can do a little sketch, and all I gotta do is follow the dots I put to the best of my ability. I'm going the wrong way. Try that again. Guys, it's really hard to draw on here. Go, 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 go. Pretend that I touched that. All right, there it is. There's my inverse. And notice that if I did have my y equals x line, they intersect there and they are equal distance. It just keeps going. Was that terrible? So if you know the domain of the original and the range of the original, do you actually need the graph to find its inverse domain and range? Nope. All right, so that concludes part B.